Black holes have got to be one of the strangest, most fascinating things in the entire universe. Seriously, they feel like they break the very rules of reality as we know it. So, yeah, let's dive right in. We're going to tackle two of the absolute biggest questions about them. First, where do these cosmic monsters even come from? And maybe more excitingly, what would you actually experience on a one-way trip straight into the abyss? To really get what a black hole is, you have to start at the beginning. And that story, believe it or not, doesn't start with darkness. It starts with the incredibly violent, explosive death of a really, really massive star. See, for most of its life, a star is locked in this perfect, constant cosmic tug-of-war. You've got the insane energy from nuclear fusion in its core, creating this huge outward push, while its own colossal gravity is trying to crush everything inward. And as long as that fusion is chugging along, that balance keeps the star perfectly stable. Inside that core, it's basically a factory. It starts by fusing hydrogen into helium, which releases a ton of energy. Now, for the biggest stars, this process just keeps going, creating heavier and heavier elements. But then it hits a wall, and that wall is iron. Fusing iron produces absolutely zero energy. It is the end of the line for the star's furnace. So the furnace is off. There's no more outward push. That delicate balance is completely broken, and gravity wins, and it wins catastrophically. The star's core implodes in less than a second, collapsing inward at a mind-boggling quarter of the speed of light. This whole implosion triggers this incredible rebound effect, a titanic explosion that we call a supernova. In that one single violent moment, all the heavier elements in the universe are forged and blasted out across the cosmos. And what's left of the core? Well, it's either a super-dense neutron star, or if the original star was massive enough, the core just keeps collapsing and forms a black hole. So, the star is gone, and a black hole is born. But what is one really? Let's break down the anatomy of this cosmic monster. First up, you've got the part we can sort of see, the event horizon. Just think of it as the ultimate one-way door, the point of no return. Once you cross it, that's it. To get out, you'd have to go faster than the speed of light, and, well, that's impossible. It's literally why they're black. Not even light can escape. Okay, so if the event horizon is the black part, the singularity is the hole. This is where every last bit of that dead star's mass is crushed down into a point that theoretically has zero volume and infinite density. Honestly, we don't really know what's going on in there. Our entire understanding of physics just breaks. I heard a great analogy for this. Trying to use our physics to describe a singularity is kind of like trying to divide by zero on a calculator. It doesn't work. You just get an error. It's a point where the known laws of the universe just completely stop making sense. All right, let's bust a huge myth right now. Black holes are not cosmic vacuum cleaners. They don't just go around sucking things up. Their gravity is just gravity. If our sun were to magically turn into a black hole of the exact same mass, you know what would happen to Earth? We'd just keep orbiting it. Now, don't get me wrong, we'd all freeze to death, but we wouldn't get pulled in. Okay, so we've covered how they're born and what they're made of. Now for the really fun part. Let's imagine you're on a journey of no return. What would it actually be like to fall into a black hole? And this is where things get truly, truly weird. All because of how that immense gravity warps time. To someone watching you from a safe distance, you would look like you're slowing down as you get closer to the event horizon. Your image would get redder and dimmer and eventually seem to just freeze forever. But from your perspective, you'd see the rest of the universe fast forward, like watching its entire future flash before your eyes. The second you cross that event horizon, space itself changes. It's not about you moving through space anymore. Space itself is flowing into the black hole, and it's pulling you with it. There is only one direction you can go, in. It's like being in a hallway where the floor is a conveyor belt that only moves one way, and it's getting faster and faster. So how does it all end? Well, physicists have a couple of theories, and let me tell you, neither one is great. The first is called spaghettification, which is exactly what it sounds like. The gravity at your feet would be so much stronger than at your head that you'd be stretched into a literal stream of atoms. The other idea is the firewall, this wall of high-energy particles at the event horizon that would just vaporize you instantly. So, take your pick. What's really interesting is that your fate actually depends on the black hole's size. A small one has such a steep gravity curve that it would spaghettify you before you even got to the event horizon. But a supermassive black hole, It's so huge that the gravity change is way more gradual. You could actually cross the event horizon without even noticing and travel inside for a good while before, things get stretchy. And when we say supermassive, we really, really mean it. The current record holder is a monster with a mass of 40 billion times the mass of our sun. Just try to wrap your head around that number. To put that into some kind of perspective, the diameter of just its event horizon is 47 times the distance from our sun all the way out to Pluto. It's an object so big it pretty much defies our ability to comprehend it. Now, for a long, long time, scientists figured that black holes were eternal, the absolute final state of matter. But it turns out, even they don't last forever. They do have a death, and it's a very, very, very slow one. To understand how that's even possible, we have to look at something that seems like nothing: empty space. Because at the quantum level, it's not empty at all. It's this fizzing, chaotic sea of virtual particles that are constantly popping into existence in pairs, and then immediately smashing into each other and disappearing. So, what happens if a pair of these particles pops into existence right at the edge of an event horizon? Well, one particle might fall in, while the other one escapes. Because the escaping particle can't find its partner to annihilate, it becomes a real particle. But to become real, it has to get energy from somewhere. And it gets it by stealing a tiny, tiny bit of energy and therefore mass from the black hole itself. This little trickle of escaping energy is what we call Hawking radiation. And over eons, it causes the black hole to slowly, slowly evaporate. Now, this process is incredibly slow at first, but it speeds up as the black hole gets smaller. By the time it shrinks down to the mass of an asteroid, it's radiating at about room temperature. When it's the mass of a mountain, it glows with the heat of our own sun. And in its very last second of existence, it goes out with a bang, exploding with the energy of billions of nuclear bombs. But hey, don't hold your breath waiting for this. For one of those supermassive black holes, this whole evaporation process will take a Google years. That's a 1 with 100 zeros after it. The universe will be a cold, dark, and pretty much empty place long before the last black holes start their final fireworks show. And all of this leaves us with one final, fascinating question. Black holes swallow everything, including all the information about the things that fall into them. So, when that very last black hole finally evaporates, in the unbelievably distant, dark future, what secrets of our universe will die with it, lost forever?